This commentary on the Virginia City Waterworks was put together in 1966 using many photos that were taken some years previous to that time. Many of the buildings and structures have disappeared since these photos were taken. This project evolved from my wife Grace's interest in photography and my interest in Nevada history. Our interest in the Virginia City Waterworks was started by a story told to me by my mother 7 years ago. She was born and raised in Gold Hill, and as a child, she and her friends would take hikes up along the flume lines. When they became hot and dusty, they would refresh themselves by opening the inspection doors and wade in the nice, clear, cool drinking water. This show was made solely for our own amusement, and we present it without making any pretense of being expert in either history or photography. In the early days of Virginia City and Gold Hill, natural springs furnished a supply of water for the use of the few persons then living in the two camps. As the towns grew in population, an increased supply of water was demanded. A water company was formed, and the water available from any source was collected in large wooden tanks to be distributed to the two towns. Several tunnels were run into the mountains west of Virginia City for prospecting purposes, and when they produced water, they became valuable assets to their owners. Finally, there are many miles of flumes and tunnels or horizontal wells, but the demand for pure water became more pressing yearly. The range above the level of the towns had been drained, and only a few rivulets of water still trickled from the mountain sponge. The bilge water from the mines were used as a last resort, but this was impure and nauseating. It was evident the water must be secured from some unfailing source. This is a view of Virginia City looking south, about 1880. The same view in 1966. Another view of Virginia City as it looks in 1966. An aerial view of the town. Over the years, many of the buildings fell or blew down, but most of the time they have disappeared and were victims of the few remaining residents who used the abandoned buildings as a source of firewood over the years. This is looking east with 6 Mile Canyon in the background. The Virginia Range, to the west of the town, is not as dry and sterile as one would think without closer inspection. There are a few springs, such as where the horses are standing. Looking east down Spanish Ravine, this was one of the better water producing areas. Looking up Spanish Ravine to the west, some of these prospect tunnels produced water, making them valuable possessions. The water was collected by means of these flumes, which ran for miles north and south of the town. The flumes north of the town are quite old, as they were abandoned in 1872 when a new source of water was obtained. The flumes carrying the drinking water were rectangular and covered, as opposed to the V-flumes used by the lumbering industry to carry wood. There are many quarrels and considerable litigation between companies who were digging tunnels for sole purpose of striking water. After being collected, the water was stored in wooden tanks and then distributed mainly by pipelines. These are head gates on the flume line used to turn the water into the storage tanks below. Early in the spring, when the snow was melting, the tunnels afforded a considerable supply of water. But in the summer, when it was most needed, they furnished but feeble streams, and these became impregnated with minerals. Standing on the site of a former wooden tank and looking up towards the flume. This wooden tank was still standing in 1966, but it's gone now. Here we are flying from north to south over the town with the flume line visible. They resorted to all manner of devices to save as much moisture as they could. They would dig ditches to the prospect holes above the flume line to save as much melted snow and rainwater as possible. At the mouth of the tunnel, heavy bulkheads were constructed to dam back the water. By damming it back in the tunnels, the water would be kept cool and pure. By using all the methods of conserving the water that they could think of, they made a giant sponge out of the mountain. The flume line winding miles to the north of the town. When a plan was proposed to conduct water from a creek in the Sierras across the Washoe Valley, even the boldest speculators were startled. To succeed would be to achieve a feat in hydraulic engineering never before attempted in any part of the world. The decision was made in August 1871, and construction proceeded in 1872 and 1873, before the great bonanza of the Con Virginia was discovered. The Sierra Nevada range that borders the east side of Lake Tahoe is higher than the Virginia range by about 1,500 feet, and peaks rise to elevations of 10,000 feet, as at Mount Rose. In addition to being higher, the Sierra lies in a region of heavy precipitation, and the snow usually packs heavily and lasts well into the summer. Between the Virginia Range and the Sierra lies the deep valleys of Eagle and Washoe Valleys, 1,200 to 1,500 feet below C Street in Virginia City. The Virginia Range is connected to the Sierras by a spur of the mountains known as the Washoe Mountains. This connecting spurs lies southwesterly from Virginia City with a gradually falling elevation until it reaches the Sierras at Lakeview, which is a pass about 150 feet above Washoe Lake and about 500 feet above Carson. The Washoe Mountains and the Lakeview Saddle determined the location of the aqueduct to supply the Virginia City with water from the Sierras. A view of the Washoe Mountains looking south from the east side of Washoe Lake. Flying over the Washoe Mountains looking west. The same Washoe Mountains looking to the east. The top of Mount Rose is sufficiently high to get plenty of snow. A view to the northwest towards Truckee from the top of Mount Rose. Looking towards Reno. Looking south over Lake Tahoe. Normally, the Tahoe area receives plenty of precipitation. A view of the Sierras from Geiger Grade. The snow usually comes early. Not only does it come early, but it stays late. There's moisture over there if it could be brought to Virginia City. In the mountains to the west of Lakeview lies Hobart Creek, flowing northerly through Little Valley where it joins Franktown Creek and descends into Washoe Lake near Franktown. The upper reaches of the creek are at a sufficient elevation to send water to Virginia City by gravity flow if it can be conveyed across Washoe Valley. We are over Little Valley looking south with the Hobart Creek watershed in the background. Looking upstream on Hobart Creek. This creek has experienced many floods and washouts. Looking downstream on Hobart Creek. Hobart Creek descends into Little Valley where it joins Franktown Creek. Franktown Creek, after it has been joined by Hobart Creek and near where it empties into Washoe Lake. This is a view of the map. There's a Version Dam on Hobart Creek. On top of the dam, upstream from the dam, below the dam, it has suffered over the years from flash floods and washouts. Quarters for the caretakers and flume tenders. This site is called Red House for obvious reasons. A modern dam has been placed shortly upstream from the old masonry dam, and Virginia City still draws its water from here. On top of the modern cement dam. Below the modern dam with a pipeline now instead of the old wooden flume. The water was brought by flume from the dam at Hobart Creek to a tank high on the hill above Lakeview, and a caretaker's house was built on top of the tank, the inlet of the pressure pipe. Another view of the house with the tank under it. We look down Carson City from the site of the inlet tank. The pressure pipe began at this point below the house and tank. The pipe was made by the Resden Iron Works of San Francisco and fabricated by rolling the plates to a cylinder and riveted by 2 lines of rivets. The inside diameter is 12 inches, and it is capable of delivering 2,200,000 gallons of water every 24 hours. There were 1,524 fitted joints secured by metal connecting rings. 1 million rivets were used, and 35 tons of lead were poured for caulking. A 1966 view of Lakeview looking north. The pipeline came down the hill from the left, under the road and the old V&T railroad, and then on up the hill to the right. It had a pressure of 865 pounds per square inch at its lowest point. The Caretaker's house at Lakeview, in use today by the present caretakers of the water system. The pipeline comes down the hill beside the house. Another view of the same hill with the pipeline. An aerial view of the same hill with the pipeline visible. This is a water tank used by the V&T Railroad to take on water at Lakeview. It was supplied by the pipeline. Standing right on the pipeline at Lakeview, looking east with the pipeline starting up the Washoe Mountains towards Virginia City. At the east end of the pipeline, looking westerly down the Washoe Mountains towards Lakeview. To make this pipe was the work of nearly a year. It was pre-fitted to every curve and dip of the terrain. It was ordered in 1872, and the last section was laid on the 25th of July, 1873. It was the world's longest and highest inverted siphon. The outlet of the pressure pipe on the east side of the valley was into another wooden flume, which carried this water another 4 miles to the 5-mile reservoir. The pipe came out of the ground and emptied into the flume. Another view of the same. We are looking at the flume winding on towards the reservoir. 5-mile reservoir was constructed in the saddle of the Virginia Range. Another look at the reservoir. Here we are standing at the reservoir and can see the flume coming towards us around the shoulder of the hill. A closer view of the flume light. Today the flume is used no longer, but a pipe brings the water to the reservoir. The reservoir is on the summit line. Mount Davidson in the background, with Washoe Valley on the left and Virginia City on the right. There were rather extensive shops and buildings here, most of which have vanished. Yeah. The reservoir received the uniform flow of water through the pipeline and flume and delivered it to the distribution systems in varying amounts during the 24 hours of any one day. In the winter, considerable ice was cut and stored from the reservoir. Also, it was stocked with trout for the pleasure of the directors of the water company. The caretaker's red house was deteriorating badly in '66. It's all gone now. The outlet control at the lower side. Another look at the control. Looking back at the reservoir as we start down the jumbo grade towards Virginia City. Another wooden flume took off from the reservoir and carried the water to Gold Hill and Virginia City. Caretakers' cabins were spotted along the whole route of the system. The water could be diverted from the flume here and run through this gravel trap. The flume line nearing Virginia City. The flume crossed a trestle when this picture was taken in 1956. The trestle's no longer standing. Once the water reached Virginia City, it was turned into the existing distribution system of flumes, tanks, and pipes. A tremendous celebration rocked Virginia City when water was first let into the pipeline. Whistles at the mine were tied down, and cannon fire roared across the city. A torchlight parade was held that evening, and many persons filled bottles of this first water from the Sierra for souvenirs. In later years, the wooden flumes have been replaced with iron pipes, and the wooden tanks replaced with metal tanks. With the advent of water from the first aqueduct in 1873, the demand rapidly increased. The Big Bonanza was discovered, and mining increased. In October of 1875, the major part of Virginia City was destroyed by fire. The outbreak of this fire made the demand for more water imperative. It has also become imperative in the late summer. Hobart Creek could not furnish enough water. It was evident that additional water could only be obtained from the western side of the Sierras. On the western side of the mountains, a small man-made lake named after Marlette, the Surveyor General of Nevada, had been made to furnish water for the lumber flume from Spooner Summit, down Clear Creek to the lumber yard at Carson, and arrangements were made to draw water from this lake. A covered box flume was built from Marlette to run north along the mountain 1,800 feet above Lake Tahoe. This flume ran over 4 miles along the mountain rim to the west, opening of a tunnel, blasted 4,000 feet through solid granite under the Comstock-era summit. On the east side of the summit, in Little Valley, another flume picked up the water from the tunnel and carried it 3 miles to the dam on Hobart Creek, where it was joined with the already existing Hobart system. A second flume from Hobart Creek to the inlet tank was built parallel to the first tank, and a second inlet tank was built beside the first one. A second pipeline was laid across Washoe Valley alongside the first one, and a second flume line laid from the pipe outlets to 5 Mile Reservoir and from there on to Virginia City. To conserve the waters in Hobart Creek, a storage reservoir was built upstream from the diversion dam of the flume, and a new reservoir was placed on this dividing ridge known as the Divide between Virginia City and Gold Hill. We are flying over incline, looking south at Marlette Lake, 1,800 feet above Lake Tahoe. Marlette Lake, showing its positions relative to Sand Harbor. Marlette Lake taken from the mountain peak above it. A view of the lake taken from its shoreline. The caretaker's cabin as it looked in 1882. The same cabin as it looks in 1966. The standard red color of most of the buildings belongs to the water company. Looking at the dam which causes Marlette Lake to be. We are standing on the dam looking back at the lake. When the water company took over Marlette Lake, the dirt and masonry dam was raised 11 feet, thus nearly doubling the capacity and providing for the storage of over 2 billion gallons of water. A view of the map. Here we are looking at the flume line at about the time it was put into use. The ruins of the old flume at about the same point as the last view. Recently, in order to supply Carson City with more water, the old system has been rejuvenated with modern aluminum pipe. If you go out in a boat today from the Sand Harbor, you can see the glint of the bright aluminum pipe high up on the mountainside. I don't know whether that's true or not today. Already this pipeline is obsolete, as they are now pumping the water from Martlet Lake over the summit directly to Hobart Creek. A lot of solid granite was blasted by the old-timers to provide a bed for the flume. Here we are looking down at Sand Harbor from the flume line. A view of the south end of the Sand Harbor State Park. This shot was taken from a boat looking at the flume line from out in the lake. The scars on the hill are caused by the flume breaking at various times, causing washouts. This picture was taken on the flume line directly at the top of one of the scars. Here the flume has reached the west portal of the tunnel, which was driven under the summit of the Sierras for 4,000 feet, and came out in a little valley on the east side of the Sierras. This part of the flume was in good repair in 1959, but it's gone now. The tunnel is 7 feet high, 4.5 feet wide at the top, and 6.5 feet wide at the bottom. The water was carried in it by the flume at one side, leaving room to walk through. The West Tunnel House, another caretaker's cabin, is gone now. We're looking west over the roofs of the cabins towards Lake Tahoe down below. This is a chimney-like structure built over the flume in order to observe the flow of water in the flume when there was deep snow. The east portal of the tunnel emerging into Little Valley. From some years now, no water has been run into the tunnel from the west side, but a considerable stream emerges from the east. In effect, it's a horizontal well. In Little Valley, the flume carries the water to the dam at Hobart Creek, where it joins the system already in use. This part of the flume is over 3 miles long. A modern touch to the old flume is the use of black sheet plastic to line the bottom of the flume and make it waterproof. Another look at the map to orient us with the storage reservoir on Hobart Creek and also the storage reservoir on the divide between Virginia City and the Gold Hill. A look at the Hobart Reservoir from the air. This same body of water from its shoreline. The dam which causes this reservoir. The control to release its water. Here we are at the top of the inlet tanks of the pressure pipe with another house built on top of the second tank beside the last tank. It's all gone now. there was a system of control to divert the water into the tanks. These gates could be operated from inside when all of this was covered with snow. Mr. Red McGovern at the left, a caretaker of the system and longtime employee of the Virginia City Water Company, tells us about it. Where the pressure pipe comes out of the second tank. This pipe is a lap-welded iron, screw-jointed pipe with an inside diameter of 10 inches and was the largest ever made in that manner at the time. As there are no rivet heads in it to produce friction, it delivers the same amount of water as the first and larger pipe. There were now 2 flume lines leading from 5 Mile Reservoir on into Virginia City. The new reservoir on the divide looks like this from the air. The flumes can be seen approaching the reservoir on the divide, standing on the banks of the reservoir. The inlet pipe is at this point. Now that the need is diminished, Virginia City has ample supply of first-quality water. In 1887, a third pressure pipe was laid across the Washoe Valley in substantially the same location and the manner as the first 2 pipes. It is made of lap-welded pipe very similar to the second pipeline. When completed, the water supply system included 3 reservoirs and Marlette Lake, over 21 miles of pressure pipe across the Washoe Valley, about 46 miles of covered box flume, and the tunnel 4,000 feet in length. The cost of the system, including flumes, dam, reservoirs, water rights, litigation, was $3,500,000.